My name is Chris. Can I get a big hi, Chris, from you guys? Give a big hi, Chris.
Hi, Chris.
Nice to meet y'all. Welcome to Danger Science. Now, raise your hand if you can think of something that might be dangerous. Is anything dangerous at all? A dangerous situation, a dangerous thing. Sir, you can't think of anything dangerous? Nothing comes to mind? You not neither? No one? All right, if you've got something dangerous in your mind, I want you to put your hand down right now and just shout out what you were thinking of.
Explosion!
Oh, very good. I heard a lot of fire in there. I think I heard some acid, volcanoes. Space is dangerous too. Yeah. All kinds of very, very, very dangerous things. And we're going to be talking about some of those right here on the Danger Science Show. Now, let's not kid around. The real reason you guys came here is you want to see me blow some stuff up, right? You want to see me blow some stuff up? I thought you did. All right, now for this first demonstration of blowing something up, I'm actually going to need a brave volunteer from the audience. You guys didn't think we were going to be taking volunteers for blowing stuff up so quickly. Tell you what, you got here first. Come on up here. What's your name? Marcus. Big round of applause for Marcus. All right, Marcus, blowing stuff up can be dangerous, so stay right there for me. I'm going to have you don a pair of safety goggles. Go ahead and put those on for me. Protect our eyes. Whenever you're dealing with anything that might be dangerous in science, your eyes are always the first thing you want to protect. So, eyewear always. Marcus, you ready to blow something up? Audience, are you ready to see Marcus blow something up?
Yeah!
All right, here you go. Marcus, go ahead and blow it up for me. I didn't lie. All right. Oh, you're great at that. Keep going, Marcus. What's that? A balloon, yeah. All right, very good. I just want you to pinch the end. You don't need to tie it off. Just hold it above your head for me, Marcus. Great job. All right. Now, what we have in that balloon right now is an example of something that is actually very, very dangerous. It is called air pressure. Will everyone say pressure?
Pressure.
Very good. What we have here is Marcus has squeezed so much air into this balloon, there's not enough space for it. It's stretching out the rubber and pushing out, trying to make more space. And the rubber, it's all the way out here. It can't go any further. It's got to try and squeeze back in and get down to that small size. They're fighting one another. There's energy trapped in that balloon. I want to let it out somehow. How can we let all that energy out of that balloon? You can let go. All right, Marcus, go and hold it way above your head. And on a 3, 2, 1 countdown, I'm going to have you let it go. All together. Here we go.
3, 2, 1.
And all the way over there. Big round of applause for Marcus, everyone. Very good. I'll take my goggles back. Thank you. And you can have a seat. Great job, Marcus. All right. Now, that was not very dangerous. But would you believe me if I told you that was a rocket? What? I know, it doesn't look much like a rocket, but a rocket has a very, very simple definition. It's something that's flying through the air like that balloon was, that's carrying a fuel source on board with it. What was the fuel for that rocket we just launched? Air pressure. Very, very good, everyone. Yes, air pressure launched it through the air, making rude noises as it spiraled all over the stage. Now, hold on a second. About this. Is this a rocket? It looks like a rocket, but do not be deceived, for this is but an illusion. Can I have another brave volunteer from the audience to help me investigate this not rocket?
I can.
You right there. Yes, you come on up. What's your name? What's that? Florencia. Florencia, come on over here. Stand right there for me. Big round of applause for Florencia, everyone. All right, Florencia. What I have for you is a very important mission. In a moment, I'm going to squeeze this tube down, and that's going to create air pressure in here, which is going to launch this thing off the top. When I do, I'm going to send it all the way up to the top of building 3 right there. What I need you to do is I need you to go into building 3, I need you to enter the gates off, I need you to talk to the person behind the counter at the gates off and retrieve the secret key to the secret stairwell and go all the way up to the top of building 3, I need you to retrieve the rocket and come back down the secret stairwell, and I need you to return the key to the person behind the desk and come out back here and give me back the rocket. Can you do that? No? Okay, that's fine. Tell you what, I won't go all the way up to the top of building 3, I'll just send it down to the ground out there. And then can you run and get it for me? Yeah, all right. Here we go. I'm going to launch it on a 3, 2, 1 countdown. Everyone count with me. 3, 2, 1. Woo. All right, go ahead and get her, Florencia. Give her a big round of applause. Cheer her on as she goes. You can do it. All right. Now, that may have looked like a rocket, but as I said, do not be deceived. That was not a rocket because it had no fuel on board with it. As soon as I launched it, there was nothing pushing it anymore. All the air pressure was left behind. At that point, it was basically a rock. It was just falling with style. Oh, there she's back. Give her a big round of applause. Thank you very much, Florenzi. I'll take that. You can have a seat. Great job. We have a different word for something like this, something that doesn't have fuel on board with it. We call these projectiles. Can everyone say projectile?
Projectile.
Very good. So we have two very dangerous things we're looking at so far. We have rockets and projectiles. But there hasn't been a whole lot of danger so far. Do you guys want to add an element of danger? Let's do it. Let's make a slightly more dangerous projectile. Now, a dangerous projectile is going to require a slightly more dangerous source of fuel. Now, this stuff right here, some of you saw me pour it in there before the show. Does anyone know what it is? Very good. This stuff is liquid nitrogen. Can everyone say liquid nitrogen?
Liquid nitrogen.
Very good. Liquid nitrogen is the air you are breathing right now. Except it's so cold, it's not a gas anymore like it is around you. It is condensed and turned into a liquid. It almost looks like water, except it's cold. It's very cold. It is incredibly cold. Would anyone like to guess how cold it is? Give me a number. Just shout out some numbers. Is it 0 degrees? Minus what? -1. Even colder than that. It's colder than -100. It's negative. Hold on, folks. It is negative 319 degrees Fahrenheit. Can everyone say, whoa?
Whoa.
That's really cold.
That's really cold.
Because it is. This is where the show gets dangerous, folks. If you were to touch that stuff, it could burn your skin very, very badly, and I don't want that to happen to anyone here. So I need everyone to raise their right hand and join me in the Pacific Science Center Safety Oath. Everybody's got to raise their hand, sir. You got to raise your hand. You guys back there, you're watching the show. Come on, you're not hiding. Come on. You guys right here, come on. You gotta join us in the oath. You're watching the show. Right hands up. All right. Repeat after me. I state your name.
I state your name.
Okay. I promise.
I promise.
That I will never, ever, ever.
That I will
Ever, ever, ever.
ever,
Ever, ever, ever. Ever.
ever
Cross the yellow tape.
cross the yellow tape.
Or do anything Chris does at home.
Or do anything.
Because that's dangerous, man.
Because that's dangerous, man.
And I don't want to get hurt.
And I don't want to get hurt.
Very good. Give yourselves a big round of applause. All right. Let's get this danger going. Now, here's the thing about liquid nitrogen. Liquids don't take up as much space as a gas. So what happens when I bring it out here, and I dump it on the ground, say, it very, very quickly turns back into a gas. There's no liquid here anymore. It's all evaporated. And that liquid, gas takes up about 700 times more space than the liquid did, which means we can create some serious pressure if we trap it in a space like this pipe right here. So what we're going to do to make our dangerous projectiles, I'm going to take these corks, and I'm going to see how many corks I can launch up into the air using only liquid nitrogen as fuel. And I want you guys to count out loud with me. Can you do that?
Yeah.
Very good. Hold on just a second. Gonna pour it in here. Let's get these out of the way. Let's pour it in here. And let's get started. My hand is protected by the styrofoam cup right now, but normally you would not catch me anywhere near this stuff. It's exceptionally dangerous. Our first true danger experiment in the show. All right, let's count, folks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm out. Hold on. 12, 13, 14. Hold on. Hold on. I don't know. What do you guys think? No? All right. It's probably done. 14 corks, everyone. Now, if any of those landed out here, I am going to need those back, so please throw those up at the stage. Andre, will you give me a hand scooping these up and put them in the cork bin while I chatter a little bit? Now, were these rockets or projectiles?
Projectiles.
Very good, yes. These things left all their fuel behind, and they shot up into the sky, but they didn't carry any fuel with them. Is there any down here? Yep, there is. All right. We are missing a whole bunch. Where did they all go? Oh, one over here? Great eyes. I don't know why they're the exact same color as the bandstand. Seems like a unfortunate design flaw. All right, that'll be good for now, I think. So we made some slightly more dangerous projectiles. Let's make a slightly more dangerous rocket. Instead of using air like we did before with the balloon, I want to use water pressure. Now with water pressure, you can get it a lot more intense. You can get it a little bit more dangerous. That's what we have right over here. This bottle right here is linked up to an air compressor, which is going to squeeze water inside of it, pushing it together, not giving it enough space. And when I let it go, it's going to shoot all the way up to the top of this cable right here, all the way up to the top of building 1. Or maybe it won't. Raise your hand if you think it'll get halfway up to the top. We have some non-believers, I see. That's reasonable, though. Maybe it won't get all the way up to the top. Raise your hand if you think it's going to get 3/4 of the way to the top. All right. Then raise your hand if you think it's going to get all the way to the top. All right, there we go. I like the spirit. I like that spirit. We're going to get it all the way to the top. Rising to the top. Just going to top it off a little bit, give it a little bit more air, a little bit more juice. Now this stuff absolutely can be very, very dangerous in excessive quantities. Too much air pressure or too much water pressure can make some very dangerous detonations. I think that's plenty. All right, here we go. Now we're going to need, since this is a rocket launch technically, we're going to need a countdown that NASA would be proud of. So I need everyone to count down with me all together. Launch in T-minus 10,
9, 8, 7, 6, 5, 4, 3, 2, 1.
We're gonna make it. Oh, I'm gonna make it all the way to the top. Is it coming? It's coming back down. I'm gonna catch it, folks. Here we go. Woo. All right, a big round of applause for our dangerous rocket, everyone. All right. Now we got rockets, we got projectiles. These are 2 ways you can have of releasing pressure. But there's a 3rd way you can do it. It's a little bit more chaotic, a little bit more violent, maybe.
Don't kick other people.
It's what I promised Marcus at the beginning of the show, but I tricked him. You guys remember what it was? Starts with blowing stuff up. Is there another word for that? Explosions. Everyone say explosion. Explosions may be the most dangerous of the 3 ways of releasing pressure we're talking about today. And that's absolutely what we're going to do next. We're going to have an explosion. How does that sound?
Yeah!
All right, let's do it. Now, do you guys know what they use to launch real rockets into space? Do they use water? Not exactly. They kind of do. They use fires. Now, fire needs a fuel to be burning something. Does anyone know what the rocket fuel is? This one's tricky. It is liquid hydrogen and liquid oxygen. And yes, when they put those together and set them on fire, it makes a very, very big explosion. It goes, and it launches those rockets up into space. Now, we don't have any liquid hydrogen here, and we don't have any liquid oxygen either, for that matter. What we do have, though, is something almost as good. We have gaseous oxygen in the air around us. You're all breathing it right now. And we have gaseous hydrogen in these balloons right here. Those are not regular party balloons. You cannot buy those in the store. Now, if I was to stick a match up to those balloons, what do you think we'd get? A big fire and a kaboom. Yeah. So, for this next part, where did I put it? For this next part, it's going to get kind of loud. Andre, do you know where the lighter is? Carlo? One more time. You're driving. Oh, okay. All right. There we go. Got it. All right. So what I'm going to do, I'm going to grab my eye protection first. Now I'm going to stick a dangerous bundle of matches up against those 2 highly flammable balloons right there. And we're going to get a big old noise. And hopefully, if it's exciting enough, it might just upset all the birds. You guys see that seagull up there? And maybe those seagulls over there. And there's probably some doves around, some pigeons you can't see, like that guy right there. If this explosion is exciting enough, hopefully we can scare all of them into flying away. Or not. We'll see how it goes. Now I'm right up next to this, and it's going to be loud, so I'm going to protect my ears. Your ears are always the second thing you want to protect after your eyes. All right. Normally I'll ask you for a countdown, but This one, I kind of just have to go when I see it. So get ready, folks. It's going to be loud. All right, hold on. We're going to try that again. False alarm. Thank you for your patience.
Are you saying tasers?
All right. Here we go. Let's try that again. Combustion, everybody. A big explosion, a big round of applause, please.
That's not the bird of the fly away.
Was that exciting?
Yeah.
That's all right, couldn't hear you. Was that exciting?
Yeah.
All right. Now, would you believe me if I told you that was not the grand finale of the Danger Science Show?
Yeah.
Would you? You wouldn't believe that? Would you believe me if I told you that wasn't even the biggest explosion in the Danger Science Show?
Yeah.
You wouldn't believe that either? Well, both of those two statements are true. We've got a much bigger explosion coming up. Now, hold on just a second, folks.